We're here today to talk about finding and factoring out GCFs, greatest common factors. A GCF includes a number and or a variable or variables, and they can be two powers. So when we're working with this, find the largest number that goes into all the numbers, meaning the coefficients or constants. If all the terms have the same variable, then you're going to include it in the GCF. And you're going to use the smallest exponent for any of the variables that are included in the GCF. If you need to, pause the video so you can catch some of this wording. So for example, if we take this top one, and we want to find the GCF of 8, 4, and 12. Well, the biggest number, the greatest number that goes into, fits inside 4, 8, and 12 would be 4. Because 4 goes into 4 once, 8 twice, and 12 3 times. Now, a lot of people will say, oh, can't 8 go in, or 24? Well, if you tried to fit 24 inside 4, 8, or 12, it would just explode. So we can't do that. It has to fit inside these numbers, not the other way around. Our next one, 12, 9, and 18. The biggest number that fits inside of 12, 9, and 18 would be 3. 3 goes into 9 3 times, 12 4 times, and 18 6 times. Well, those are all easy ones. What happens when you have something like this? It's not easy to, off the top of your head, come up with a value that goes into all 3 of these. So I'm going to separate these. Well, I think I drew that a little long. I'm going to separate these so that it makes it easier for me to determine what's going to go into all of these and have it be the greatest common, not just the common, but a greatest common factor. I'm going to pull out a 2, and 2 goes into 126, let's see, 63 times. And then this is prime factorization, by the way. Let's see, 9 times 7 is 63. And for some reason, this seems wrong to me, but it's right. Okay, let's keep going. And 2, 3, 3, 7. Okay, no, that is correct. All right, now I'm going to move over to here, 90. Well, 9 times 10. 9 is 3 times 3. 10 is 2 times 5. And then over here, that's why I was thinking it was off. 2 goes into it in 81 times. And then that breaks down into 9 times 9. 2, 3, 3, 3, 3. Okay. We want to make sure that we are looking at the bottom of each of these and nowhere else. So you want to make absolutely certain that you bring everything all the way down. This 2 didn't change, but it stayed along all the way down. Okay? You want to look at the very bottom and not leave any numbers further up. So always bring those down. Let me get rid of those circles. And, oops, there we go. So when we go through this, let me pick a color we haven't used. I guess I'll use black. All right. I need something that's in all of these last lines. For example, 2 is here, here, and here. So I underline it in all 3, and then I write it down in the GCF once. Now, to make sure I don't make a mistake and recount something, I'm going to make a slash through it so that I know I've used up that 2. It has to be in all of them to count. I've got a 3 here, a 3 here, and a 3 here. I'm going to multiply times what's already there. Cross it off. I've used up that 3. Now there are more 3's that are in all 3 of them, like this one. So I'm going to write that down because that's in all of them, and I include it. I cross it off. Now all I have left is a 7 in this one, a 5 here, and 2 3's here. There's nothing in all 3 of them that are in common. So when I multiply this up, 2 times 3 is 6, times 3 is 18. That is my GCF for these 3 numbers. Now we've talked about numbers as in coefficients typically so far. We have yet to talk about variables. When you have variables in all of your terms, you need to make, if all 3 of them have the same letter, if all your terms have the same letter, you're going to include it in the GCF, and you're going to go by that letter's smallest exponent. Smallest, not biggest. The smallest exponent here is 3, so that is going to be my exponent for my GCF x value, x term. If I look down here, I'm going to look at all of these. X is going to be part of my GCF. Y is also part of my GCF. Z, oh, no Z. So Z is not in all of them, it's not part of my GCF. Smallest exponent for X, 4, 9, 2. Well, smallest exponent for X is 2. Smallest exponent for Y, let me just erase those so that I don't look at that again. 2, 7, 4. Well, 2 happens to be also the smallest exponent for Y. Now, when you're working with these, if one of them does not have an exponent, it's understood to be a 1. So if you don't see an exponent and you don't have that in the top of your head that it's not there, it's got to be a 1, write it in. That way you won't forget. All right, let's take a look at our next example here. I would like you to try these 2, and after you've paused the video, and then unpause, and I will do it out with you. All right, so hopefully you've done these and you did well. Here is the result. X is in all of these, so X, smallest exponent for X is 2. Y is in all of them, so I'm going to include that with the smallest exponent of 4. Z is not in all of them, so Z is not included. Down here, X is in all of them, so X, smallest exponent would be to the 6. Y is in all of them. Smallest exponent here is to the 4th. And Z is also in all of them. Smallest exponent is a 1 because it's understood to be a 1 here. Do you have to write it? No. Can you write it? Yes. So X to the 6th, Y to the 4th, Z, or Z to the 1st there. All right, let's take a look at combining the coefficients, the numbers, and the variables together. In this one, I'm going to start with my coefficients and then work to the variables, because usually you write your coefficients before your variables. 8, 16, and 24. The number that will go into all of them without going over is 8. 8 goes into all of these evenly, and it's the biggest number. So that's the number part of the GCF, or the coefficient of the GCF. The variable part, x, and the smallest is to the 2nd. Y is in all of them. To the 1st is the smallest. There is your GCF. The biggest thing I see people do is they get problems like this and they forget to do the variable part, or they forget to do the coefficient part. Both parts have to be done. Now, it doesn't mean there's always a variable or always a coefficient other than 1, but you have to look for it. Down here, 15, 30, and 20. They all have a 5 for a GCF coefficient. And then they all have an x with the smallest exponent of 3. Hopefully you got that. If so, give this one a try. See if you can come up with the GCF. Pause it and see what you get. Hopefully you were able to get, let's see, 45, 15, and 75. Well, 15 fits inside all of those. 3 times 15 is 45, 5 times 15 is 75. They all have an x and they all have a y. The smallest exponent for x is 1. The smallest exponent for y is 2. So 15x squared y. That would be a GCF. All right, now that we can do finding a GCF, we're going to learn how to factor out a GCF. First step is to do what we just did, find the GCF. Once you have it, write it down, and then open a parenthesis after, not around the GCF. Divide each term in the polynomial by the GCF and write the answers inside the parenthesis. If the GCF is 1, just rewrite the polynomial. You don't have to write 1 then the polynomial. Here's an example. So as we said before, the first step is to find the GCF. 24, 12, and 6, 6 goes into all of those. X goes in, and the smallest exponent is a 3. So I open a parenthesis. Now I need to divide each of these by the coefficient, the GCF, which is 6x to the third. So I start by dividing the coefficients. 6 goes into 24 4 times. X to the fifth divided by x to the third. Remember, when you're dividing variables to a power, they have to have the same variable to do the division, and they're both x. So you subtract big minus small exponent, and that gives you x to the second. 12 divided by 6 is 2. X to the 4 divided by x to the 3 is x to the first. You don't have to write the 1. Well, wait a minute. It's going to be minus 6 divided by 6. Isn't that 1? In fact, it's 6x to the third divided by 6x to the third, which is 1. So when I'm doing this division, the x to the third, that really means x to the 0, right? Because when I'm going to subtract exponents, and anything to the 0 power is the number 1. So I end up with 6x to the third, 4x squared plus 2x to the first, or 2x minus 1. If you don't have this minus 1 here, you wouldn't be able to have this term when you distribute it back out. And that's why you have to include that 1 in there. All right, let's take a look at some more examples. Give these a try, see if you can do them, and then I'll go over them with you after you unpause. Here we go. Let's see, 16, 32, and 20. Well, I definitely know 4 goes into that, and x, smallest exponent, 2. I do my dividing. 4 goes into 16 4 times. X to the 4 minus 2 is 2. Negative 8x to the first plus 4 goes into 25 times x squared, they cancel out the x's. So there's not going to be an x there. Down here, the GCF would be, well, there's no number part of the GCF, no coefficient part other than 1. X is in all of them, y is in all of them. So x, smallest exponent is 1, y, smallest exponent is 1. So now I'm going to do my dividing. Now these coefficients aren't going to change. The 3 is still going to be there. I'm going to divide x by x squared by x. That gives me x to the first. The y's cancel out because it's 1 and 1. 4 stays there. X's cancel out. Y to the 3 minus 1, 2. and then minus the x's and y's cancel to a 1. And there is your answer when you factor out that GCF. And that's it for today. I hope that was helpful. Have a great day.